How do you find the average value and RMS value of this waveform? I had made a graphic animation for better understanding. Continue to watch the full video if you wish to learn. This video is the presentation of sinusoidal waveform. You will learn how to find the average value, and RMS means, root mean square, value in alternating current, for any time varying signal. We looked at this waveform, basically, a visual representation of the variation of a voltage, or current plotted to a base of time. The time taken for an AC waveform to complete one full pattern from positive half, 0 degrees to 180 degrees, to negative half, 180 degrees to 360 degrees, and back to zero baseline again, is called a cycle. One complete cycle contains a positive half cycle and a negative half cycle. The time taken by the waveform to complete one full cycle is called the periodic time of the waveform, and given the symbol T. How do you calculate the average value? The average value, or mean value of an alternating current, is the average of all instantaneous values during half cycle. Can be defined from this waveform. Next, how to calculate the RMS value of this sinusoidal waveform. RMS value is called the effective value in alternating current, can be defined along these lines, is the same as direct current. Let us proceed with the derivation of these two waveforms in electrical AC system. From this positive half cycle, we can define the average value, using the analytical method, refer to calculus. Firstly, find the equation of the area, under the curve from this positive half cycle. Area is equal to, Vp, means peak voltage, times the integral, of the function, sine theta, d theta. Consider as, equation number 1. Secondly, find the equation of the average or mean value. The average value is equal to the integral of the peak voltage times the function of sine theta, d theta, and divided by pi is the radian value below the curve or half cycle, as equation 2. The integral of the function, under the sinusoidal curve, is limit from 0 to pi radian. For integrating the sine function, refer to integral tables, of trigonometric form, and integral of sine theta, is equal to minus cosine theta. Now, do the integration, and substitute the values. Average value, is equal to peak voltage, divided by pi, times the minus cosine theta, and limit, 0 to pi. Substitute the upper limit, of cosine pi, minus the lower limit, of cosine 0. The value of cosine pi, and cosine 0, the result is 1. The sum of minus 1, and minus 1, is equal to 2. And the average value, is equal to 2 times the peak voltage, Vp divided by pi, the result is 0.6366. As option, we can calculate the overall area under the curve of half cycle, then divided by pi radian, we'll get the same result of 0.6366. Another method is using the sine function of angular velocity, w, of the motion, is defined in radians per second, as the angle moved, through per unit time, and is related to the frequency. As shown on the screen, the result of calculation. If you may have question, please comments on this video. This is the waveform of average value of 0.6366. Now, you learn how to calculate the average value. If we define the average value in full cycle, the result of average, or mean value, is 0, because the area above the horizontal axis, the positive half cycle, is the same as the area below the axis, the negative half cycle, and thus cancel each other out. Let us proceed. The derivation of RMS value. Firstly, get the equation of the average value, or mean value. The average value is equal to the integral of the peak voltage times the function of sine theta, d theta, and divided by pi is the radian value below the curve or half cycle. Consider as equation number 1. The root mean square is defined as the square root of the mean square of the average value. Now, do the integration to get the value. VRMS squared is equal to peak voltage then squared times the integral of the sine function divided by pi. Under the sinusoidal half-wave from 0 to pi radian. Let's substitute the derivative of sine squared theta is equal to integral of 1 minus cosine 2 theta d theta divided by 2. The following is the solution for the integral method, and understand carefully. VRMS value is equal to peak voltage divided by square root of 2. The final result is 0.7071 times the peak voltage. Now, you know how to find the RMS value. Thank you for watching, and don't forget to subscribe. See you again.